We are going to talk about the Google Maps API, including a few new features and a general overview over all the features. So before we begin that, I want to give you a little perspective of why we are using maps in the first place. The thing about Google is, or an interesting thing about Google is its interesting mission statement, which is to organize all the world's information. Part of the mission statement is it, and to make it universally accessible and useful. So now it turns out that there are actually not that many fail-safe ways to organize information in the first place. There are actually only two fail-safe ways, which I'm going to show you in the next 3 bullet points. So the 0th way to organize information is not to do it at all, but to just search for it when you need it. And that's something Google is very good at, right? So the other fail-safe way to organize information is to just order it chronologically. And the blogging revolution that happened over the past 10 years or so is actually a witness to that. So try to remember personal homepages or personal websites before the idea of the web was of the weblog was invented. So they were usually structured in some awkward way. So my house, my cat, my resume, whatever, and it was usually uninteresting and not very easily to navigate. So in all these ways of trying to organize the information by categories or by some navigational pattern generally failed. In contrast, just writing arbitrary stuff for your web page and just order it chronologically by order of time you invented it just works perfectly well. And all the blocks are useful and fail-safe to use and easy to navigate and so on. And it turns out that the other fail-safe way to organize information is to put it on a map. That is, if you have information and you don't know how to organize it, and it has some geospatial relationship, then just put it on the map and you've done nothing wrong yet. So that is, this works actually pretty well. So putting things on a map is a good way to organize information. So the Maps API, the Google Maps API, helps you to do that, or to accomplish this. And it does so in a variety of ways, or you can consider how to do it in a variety of ways. So the simplest way to understand what the Google Maps API does for you is to consider it as a huge library of HTML elements for places. So consider the image element in HTML. So whenever you talk about some particular image in an HTML document, you don't need to talk about it, but you can just use this ing element in HTML and just include this image into your HTML document. And the Google Maps API does something similar for places. So whenever you talk about a location, you don't need to talk about the location and to describe it and do whatever. You can just include a Google Maps API in your document and point to that location using this Google Maps API map. So beyond that, this is not really an element, right? Because it involves JavaScript and some scripting, but conceptually it is something like an element. But this element also provides you with behavior. That it is not just a static part of your content that it provides to you, but it actually augments the behavior of your page by providing all this sophisticated dragging, interaction, and so on, to which I come in detail in a little moment. But it is an alternative page format for your content. So instead of drawing up large lists or long lists of locations, for instance, or of anything that has to do with a location, instead you can take this list and put it on a map and convert it into a cloud of markers. So that is, you can structure your pages differently. And last, it is at the most sophisticated or complex level, it is an application component for mashup applications. That it is a building block for building complex and sophisticated distributed web applications. Just to look at it very briefly, so the API, this you all find online in the API reference documentation. But I just want to give you a bird's eye overview of the structure of the API. So at its core, the API, of course, has the map object. And around this map object, there are some objects that provide particular aspects of the functionality. For instance, user interface provides controls that you can put on a map in order to augment the interaction that is possible with the map. Content is provided in the way of different map types, like the satellite map type and the map, of course, so the base street map and the hybrid of the two. And then there are simple overlays that just represent data, so something like the marker and the info window and lines and polygons and so on. And overlays that are more complex. So in the sense that the data that you put on the map using this overlay is not contained in the overlay at the time you create it, but actually you create an overlay, and then this overlay goes ahead and fetches new information from some remote services. And this is true for the newly released traffic overlay, which I demonstrate also, which provides online real-time traffic information for streets in particular streets in particular cities so far in the US. And GeoXML is a way to put the content of a geographic feed format, be it KML or be it GeoRSS, on the map in one fell swoop. And there are services that still more emphasize the connection of the API application with foreign services to augment its behavior. We released the geocoding service. That is the service that takes an address and translates it into a point on the Earth a year ago. And recently, like this week, we released the direction service, which is the same for directions as the geocoding is for addresses. I'm going to show you this as well. And very soon, we will release the Ads Manager, which is basically AdSense for maps. So you can put AdSense maps on your map, just as you can put AdSense maps on your HTML page already. There are a few other interfaces that make up the API. Most interesting of which is probably the extension interfaces, which allows you to create some custom subclasses of the core classes that are provided by the API. Let me see what I can do for you. Much better. Yeah. Okay. Let me just demonstrate the properties of this map widget. So you have noticed that my slides are written in HTML, and the Maps API is meant to put a map into any HTML document, and in particular, I put a Maps API map in this HTML document. So this is a Maps API map, actually. So, and this is the standard behavior of the Maps API map, that I can just take it and drag it around. So there are no arrows next to it that I need to click on it in order to get a new page with a new map that is just shifted by a little bit, but I can just drag it and take it. This behavior can be modified in a way. So for instance, if I double-click this now, then it centers on the point I double-click. I can switch this to zoom on double-click. So if I double-click this, then I can zoom in instead. There are a few modifications that are possible in the API. I can put content on the map. So for instance, markers. This marker is in Tokyo. It actually has a tooltip. It is the Golden Pavilion Temple in Kyoto, not in Tokyo. Okay. Info windows are these adornments to markers that you can show either directly or on click. And we can show polylines. So these are these static data that I mentioned that I can put on the map. I can also remove them. It is also possible to create more complex behavior of these overlays using mechanisms that are provided by the API, which are all based on event handling, basically. So this is a marker that highlights on rollover. So if I go over it, then it highlights. I can also build more complex behaviors that allow me to edit the map content. You probably have noticed the release of the My Maps tab on the Maps application. So this map shop thing that allows you to create maps, personal maps overlaid on the Maps application. And the editor that is part of this is basically implemented in these terms. So, or in terms of the functionality that are also exposed in the Google Maps API. So here's a very simple behavior an editing behavior. So wherever I click on the map, I just create such a marker. And if I click on a marker, then the marker goes away. So that's it. This is written in maybe 3 or 4 lines of code or something. Very easy. Marker can also move by themselves. So this marker, for instance, if I try to grab it, just moves away, though I don't know where, actually. Yeah. No, it's entirely gone. This is the marker that we've seen before. These are all these markers that I put in Rio de Janeiro. And I can also give dragging behavior to this marker, which is I can take it, and then I can drag it around and position it somewhere else. And at this point, I want to make a brief remark about this particular shape of our markers. And it's actually, it might seem that it is just a funny idea to have these markers that have this balloon shape and behave in this particular way as they do. But actually the fact is that these markers are meant to point very precisely to a particular point for once. So that's why they are why they have this tip, this very narrow tip. And the point to which they point, indeed, is minimally occluded by the marker. That is, the marker doesn't cover the point to which it points. And this is very important, and this is a very important distinction to other markers like arrows or whatever, just tiny rectangles or stars or something to mark locations, which all don't have these properties. And particularly, if you try to position a marker, then we even lift up this marker. Let me show that maybe more closely. So we lift up this marker and just mark the point to which the marker points by this cross, which even less occludes the point to which we want to position it. So this is actually, so it's just not meant to be funny, but it's actually meant to be useful, this particular graphical feature of these markers. Okay, let me remove those. Oops. These are examples of the more complex overlays. So this is a tile layer overlay. That is actually an overlay that you will see shortly, hopefully, that allows an API application to put its own map tiles on the map. So if I drag this map, then you see that I get an alternative map that is just overlaid on the standard map, this time of the Stanford campus. Another example is a ground overlay, which is similar, except that it is not tiled. So it is just put on the map as a single image. And in this case, it is, for instance, an image of the, what is it, the Etna volcano in Sicily. Yeah. Another example are KML feeds. So all these markers are generated all at once by just loading a KML file from a URL. And lastly, I mentioned that we have this traffic overlay that shows dynamically the current traffic conditions on the map. Let me just try if I find some controls. Yeah, I want a control here, actually. I also want a map type control, and the scale can't hurt. Okay, I just skipped the slide on the first. Okay, now I can actually zoom in, for instance, or actually I can zoom out, which gives an interesting view of this traffic overlay. So this traffic overlay, if you zoom out very far, then it just marks all the cities for which we have these traffic informations by these little traffic light icons. And here you see that, unfortunately, we only have this for the US right now, and we don't have it in Europe yet. Okay, if you go to one particular city, then you can zoom in, and you can get, again, these traffic overlays. So this is actually, conceptually, at the API level, this is a single overlay. That is, you just create this G-traffic overlay and put it on the map, but it provides a very complex both data structure and behavior that it projects on the map. Let's remove this. Geocoding is one of these services that we provide as part of the URL. I just type an address, and basically I get back the location of the address that I typed in. The same we have nowadays for driving directions. So I can just ask for driving directions, for instance, from Berlin to Hamburg. And I actually should get driving directions, except that they should be written here, which they don't right now, which I don't know why that happens. This is to give you a very brief impression of how a Google Maps API application looks like in code. So this is, as you see, a full HTML page, and this is a full Maps API application. So what you need in order to use the Maps API is to include a script that comes from google.com. So it's this maps.google.com file equals API. Actually, what you have to append is also an API key that you can obtain from the Maps API website, which I omitted here because it's rather lengthy and doesn't add any value. Okay, what happens then is this is just an HTML page, and in this HTML page we want to have one map. And this map we put in this div that we call map, and we just set the width to something definite. And what we then can do is we can create a map object using the Maps API calls in this function hello. And this function hello is actually executed, as you see above, in the onload handler of this page. And what happens here is we create this map object to whose constructor we just pass this the DOM node of the element into which we want to project this map. Then we center the map on some initial point, and at that point the map becomes visible, right? And what we then do is we create a marker, which we position at the same point at which we centered the map, actually. And then we put this marker on the map using this method addOverlay. Then there's a marker on the map. And then on this marker, we open an info window to which we pass the string hello world. So, and this is the famous hello world application that you write first for every toolkit programming environment or programming language that you start working with. So, and here is how this looks like. So I first clear whatever I had before. And this is hello world. So basically what I do here is I call this hello function, and the map was obviously set up before. But this is the effect of this hello world, which gives a nice twist to the meaning of hello world in this hello world application. Okay. So with these features of the Maps API that we released 2 years ago, almost, not to the day, but it was in June 2 years ago. So since we released that, many thousand Maps API applications have been built all over the web. And for instance, today, if you go out and search for something that has a spatial relationship or a spatial aspect to it, like finding an apartment, you usually go to a real estate website and you find houses, and these houses are posted on a Google Maps API map. You probably want to know what the area is about that you buy this house in. So you go to another website that shows you all the crimes or the crime statistics mapped out into a Google Maps API map. And if you have children, you are interested in good schooling for them, and you find another website that shows you good schools, again, mapped on a Google Maps API map. This is really great, although I guess you get the impression that this is somewhat inconvenient because it's basically information about the same area, and you want all that information on the same area. And moreover, all these Maps API applications have significant user traffic, of course. So that goes into the tens and hundreds of thousands unique users that these sites have. However, on Google Maps, there are millions of users who look exactly or who search exactly for the same things that are provided by these Google Maps API maps, by these Google Maps API applications. So, and therefore, the solution to that problem is to take the API or the Maps API mashup and turn it into a part of the Google Maps application. And the technology to do that is Maplets. So, and I'm going to give you a brief demo of that, I hope. So this is the Google Maps website. And here I am logged in already to my account. And now I have this third tab on the panel, which is called Maplets. And on this panel, I have lots of maplets that are already predefined there. And these maplets are tiny plugins to the Maps application that have exactly the same functionality as Google Maps websites, as Google Maps API websites, except that the map onto which they put their data is not one map for each of them, but is one single map for all of them. That is, I now have this, what is it? I have this Hello World maplet, for instance, that puts its Hello World message here. Then I have this Google Real Estate Search maplet, which allows me to search for apartment listings. Although I think it will not find anything in Europe yet. Oh, it does. No, see. Here. So now these apartment listings come from this apartment search maplet. Another thing I can do is to provide new behavior to the map. For instance, if I would want to go around and visit all these apartments, which I probably don't because my search was completely arbitrary and I don't want to rent an apartment in Italy right now, I can map out the distance of the way that I need to travel in order to see all these listings using this distance measurement tool. So, and every click on a map just sets a new waypoint for my distance measurement tool, and it shows me the total distance of all the waypoints that I clicked so far. Luckily, I can reset these, which is very useful. I can also switch off these maplets again, so I'm not bothered if I don't need them anymore. And so on. There's actually a directory of content where all the known maplets eventually get published. And this gadget directory has a few of them right now. So these are the obvious things like Google Real Estate Search, Chicago Crime is there, Earthquake Search, not always very important, but sometimes useful and interesting, and so on. And all these things you can just basically add to your homepage. I just add a few random ones. And when I go back to Google Maps, I just have them all on in my personal profile. Here they are. There are a few more now. Okay, so much for a brief demo. As I said, you find this on maps.google.com/preview because the Maplets feature is not yet released to the general public yet. So that's a developer preview, but we will release that very soon. And you have the same on maps.google.de and all the other maps.google domains. Okay, so what are Maplets more specifically? So Maplets are created as a mashup of APIs, so to speak. So we have for a while this Google Gadgets API, which basically allows you to create such third-party plugins for your personalized Google homepage. So, and we combined that with the Google Maps API. So that is these maplets, or these gadgets, now can be plugged into a page that already has a map, namely the maps.google.com homepage, and they can, using an API that looks very, very similar to the Google Maps API, talk to that map. So, and this is all it takes, basically. And what that means is that a maplet is a Google Maps API that is turned into a plugin for Google Maps. It is also a way to create, so to speak, mashups of mashups, right? So you have two Google Maps mashups, and you can now mash them up and put their information on the same map. Okay. Here again is how this looks like in code from the developer perspective. And a gadget, to begin with, is just an XML specification of wrapped around some HTML content that eventually is shown in this little rectangle on your application. So it is called a module. And this module starts with having preferences, like so much in life. And the only preference that a gadget needs to have in order to be a maplet is it needs to require this feature shared map. This shared map is exactly the map that it shares with all the other maplets in the same page, right? And once this maplet, this gadget requires this feature, it has the Google Map available, or a Google Map API variant available to it that it can use in order to talk to this map on the page. So, and the rest of it is basically HTML content. So, and this HTML content is text, which in the case of the Hello World maplet is obviously Hello World, and it can be script. And the script can create a map, which in this case doesn't take an argument in its constructor because the map is already there, and we don't want to attach it to an existing HTML element in our own page, but it's actually a map that is outside our own page. And then we can do exactly the same thing. So we can point it. We can point the map to a point on the Earth. We can create a marker. We can add this marker to the map. And we can open an info window on this marker. Only this time, this marker will be put on a map that is on the maps.google.com page and not in our own iframe. And then, once you load this on the Maps API, on the Maps application page, it looks exactly like we've just seen. Okay. How do we accomplish this? You might wonder how we can allow JavaScript from other people's pages to run on maps.google.com. So you should be aware that this is actually nothing that you would want to allow. So to accomplish this is actually to run foreign JavaScript inside a particular page is actually the essence of an attack that is called a cross-site scripting attack or script injection attack, and that leads to privacy violations and security violations and so on. So, and the answer to this is we don't allow this. So, and in order to prevent foreign JavaScript to interfere with the personal settings of the users of Google Maps, we run this maplet in an iframe that comes actually from a different domain than the Google Maps application. So the map itself, the Maps page that is loaded, comes from maps.google.com, and the iframe that this maplet runs in comes from a domain called gmodules.com. So on gmodules.com is also a server that is run by Google, but this server fetches the content from eventually your server that hosts this maplet specification, this XML file that we've seen. This server takes this XML file, reads preferences, inserts user preferences, and turns this into an HTML document that is then sent into this iframe. So, and because these iframes, or this iframe and the main page, come from different domains, they cannot talk to each other. And this JavaScript that runs here cannot inspect the contents of this page and spy on personal information or manipulate personal settings and all the things that you usually want to prevent other people's JavaScript from doing. So, now the question is, of course, that is very well that they can't talk to each other, but after all, the whole purpose of this maplet is to eventually talk to this map and put stuff on the map. So how do we accomplish this? Here's how we do this. We don't call JavaScript functions directly. Instead, whenever a JavaScript function is called, the invocation of this function is serialized. That is an ID for the function invocation, and an ID for the object on which we invoke this function as a method, and all the arguments are serialized into a string. And then they are transmitted in the following way to the other side of the iframe, so to speak. So this iframe creates inside itself a tiny new iframe. Well, it's actually not tiny, it is invisible. So it doesn't matter how big it is. So it creates an invisible iframe and loads into that iframe a document from the maps.google.com domain, which is predefined to be there. And these data that encode the call are appended to the URL of this document in the fragment identifier part. That is this part after the hash map, after this hash part. And this means this part is not transmitted to the server at all. So that is from the server, a static document is loaded. And this document contains just HTML, which just does one single thing. In its onload handler, that is when this document loads, it looks on its own URL, reads the hash part, takes this hash part, and gives it as an argument to a function in the top-level iframe that is defined to be there. So, and because this document was loaded from the domain of the maps.google.com page, it can actually do this. So JavaScript that runs in this iframe can actually call into JavaScript that runs in this iframe. But a JavaScript that runs in this iframe comes actually from this domain and does very limited and very strict things. It does, the only thing is to forward these data encoded in the URL, nothing else. So, and this is the way how we transfer a request from the iframe or from the maplet that runs into this iframe on a foreign domain to the main page to put something on the map. And the same happens for, or something very similar happens for the way back, because we obviously want to get responses also back for the requests that we send or for the method invocations that we do on this page. Okay. It's lucky that I explained that already because my page is too small actually to show you all this. Good. This has an important consequence for the structure of the API. So I mentioned already that the Maplets API is essentially the same thing as the Maps API, except for a few differences. So the first difference relies or rests in what I've just explained. So if we call in the Maps API, if we call a method that returns a value, we can just get back this value because we talk to this map, and if we want to get the zoom level for this map, the map can tell us the zoom level. However, if we do the same thing in the Maplets API, then of course the map stub object that we have inside this iframe is nothing like the map itself, right? It is just a stub object whose only purpose is to forward these requests to the actual map. And these go through this awkward chain of iframe responses and so on. That is, this method cannot actually return its return value. So what we do instead is this method accepts a callback function. And this callback function will be invoked with the return value once it is available. So in this case, the zoom level. Now this is called asynchronous invocation. And this is actually a very common idiom in the world of interactive programming, particularly in the world of JavaScript, because JavaScript is single-threaded and you cannot block a thread because then you block the whole browser. So, and this is what you see a lot in the Maplets API, and this is one of the main differences to the Maps API. Another difference is, of course, that we don't allow Maplets to manipulate all aspects of the map as freely as we allow it to a Maps API application. A Maps API application owns its map, while a Maplet doesn't own the map. So, and therefore, a maplet cannot disable that the map is draggable, for instance. In a Maps API application, you can do this. You can freeze the map. For a maplet, it is not possible to freeze the map for the whole page. And I explained how we prevent foreign JavaScript from actually running in the main maps.google.com page. And of course, all the JavaScript, all the Maps API functionality that it would involve to actually transfer JavaScript into the maps.google.com domain in order to run it there are not possible in the Maplets API. So for instance, we don't support custom controls and custom map types, because a custom map types involves implementing an interface that is provided by the API and then instantiating this implementation. And this doesn't work because we would need to send this implementation across the frame boundary. And also, we filter contents of info window text to remove all JavaScript. So that means mostly removing JavaScript URLs from all places where URLs can occur, and basically removing URLs. And also removing a click handler, of course. So like on-click attributes in HTML are just removed. Okay, another thing that I would like to talk about quickly is the data-driven aspect of the API. So this happens very often. So the data that are going to be put on a map as markers, for instance, are just part of the programming code, and they are just there in data structures. The problem with that is there are two problems with that. First, it is very difficult to index these data. So you can search for Stanford University on Google Maps, on Google, and you are very unlikely to get this Maps API application as a hit, because it's very difficult to identify keywords in Maps API applications and to make a meaningful reference to such an application. The other thing is, if you do this in a maplet, then you have to transfer all these data across this frame boundary. However, if you specify your data separate from your code in a file format that is suitable for it, so for instance, KML, which is the keyhole markup language, which is the annotation and extension language for Google Earth, or in GeoRSS, which is an extension to RSS to allow geographical markup. So if you put your information there and put these files somewhere on the map, on the web, then they can be properly indexed and they can even be displayed on Google Maps. And if they are indexed, then they are also displayed, or parts of them are also displayed as search results to local searches on maps.google.com with a pointer back to your Google Maps application if you provide this backlink as part of the file. So this basically makes your Google Maps API application and your maplet content searchable on maps.google.com, which is very useful. Okay, as an example how this document format looks like, this is very similar to the data that we just seen in JavaScript. This is a simple XML format. So KML is just an XML instance, and it has particularly these placemark elements, which just give a name to a particular place on Earth that is identified by geographical coordinates. And with that, you basically can externalize all your data from your application and make it usable. And at the code level, you just don't have to write loops around your data structures or something. So you can just put it on a map using this GeoXML object that is both part of the Maps API and of the Maplets API. And if you use this in a maplet, then all that needs to be transferred across this frame boundary is not the information of all the individual markers, but it is just this single URL. And then the URL is being taken care of on the other side, because that's something what we do anyway by our code. So, okay. So to conclude, I want to give you, a brief roadmap on ways to create your personal maps, basically. So since a few months, we have this My Maps drag and drop editor as part of the Google Maps application. That is with a very simple interface. You can basically create your own maps, put markers in them, lines in them, annotations, whatever, and publish them so that other people can see them. And they are also searched, indexed and searched automatically once you publish them. This is suitable for small maps with static data. In KML, you can create larger data sets than are suitable for interactive editing on the Google Maps application, and they can even be dynamic in the sense of network links or of parts that are dynamically refreshed, and so on. But still, the display of these data is mostly largely static, or at least with generic behavior. So these feeds are displayed as icons, and you can click on these icons, and then the information associated with these items is displayed in an info window. And this is standard for all these KML feeds. So, and you use maplets if you really need a custom application-specific user interface to manipulate the data elements that you want to put on the map, or if you don't want to put any data elements in that sense on the map, but just create new behavior for the map. So like this distance measurement tool that we've seen. So the distance measurement doesn't put any data on the map. It is just, it creates new behavior for the map. Okay. With that, I would like to conclude. Again, remember this URL. That's the developer preview for the maplets. So far, thank you very much for your attention. Okay, I guess we have a few minutes maybe 2 minutes for questions, and then we conclude and take the other questions up here. Yeah? Oh, can you speak up, or maybe we have a microphone? Or anyway, since, yeah. Oh, the question is how to prevent spamming.
Yeah.
And well, all the maplets that appear on your homepage, on your personal page, you've selected to be there. And it's just one click of a mouse to make them go away. So it's this close button, basically, or this remove button for the maplet.
It will be human-generated, the prevention. Humans will see all the things and decide.
If a gadget is clicked, well, first of all, you see the gadget in the directory only if sufficiently many people have it actually on their pages. So,
which is relevant number, for example.
Some relevant number, yeah. So if nobody has it on its pages, or if people tried it and clicked it away, then it doesn't show up high in the directory in the first place. So and this works very well for gadgets. So I mean, this whole directory is in use for the homepage gadgets directory. And this just works. So if something is annoying, then people just click it away and that's it. So there's no real potential for spam, at least nothing has realized. And so we expect very much the same from applets, to conclude this question.
Thank you.
Mm-hmm.
Is there any support in the Maps API for a third or fourth dimension for markers, something like altitude or time constraints?
In the Maps API right now, there is nothing to support that.
Why not?
Because maps are flat, obviously.
Okay, but when I think of making a conference or something like that, I'd like to put the timetable on such a map, maybe, and then time constraints would be quite interesting, I think.
Yeah, I mean, right now, there's nothing in the Maps API either that prevents you from implementing such a thing. So, I mean, if you want to give your markers a timestamp and then only show markers with a timestamp within a certain window, then you can do that very easily.
Okay.
So, but yeah.
Okay,
so
thanks.
much. And by the way, in KML, which you can just use to throw things on the map, there is support for a third dimension, so for altitude in all the coordinates. Only the altitude is ignored when you put a KML file on Google Maps.
Okay, thanks.
As of now. More question? There's one there and one here, and then maybe we conclude because we run over time, and I'll be available for more questions.
Just a very short question.
Yeah.
How large is a large KML file? You just pointed out that KML is useful or applicable in case of larger sets of markers.
Yeah.
And you use the words large KML. So how large is it? 1,000, 10,000, millions of points? No, certainly not.
Large has gotten larger recently because we now support incremental transfer of KML file content into the Maps application. So that goes to a few megabytes at least. But at some points, I think it stops making sense. I don't know what the limits are right now. So there are limits, but they've just increased. And we do incremental transfer of content to the browser.
Okay. I typically can include thousands of markers on a map. Would that be a problem?
Thousands of markers are still a problem on a map.
Okay.
Yeah. Mm-hmm.
Last one.
And we had this one.
Is there a way to, I have an existing Google Maps application on my website. Is there a way to let other users put maplets on my own website, or is maplets just limited to maps.google.com?
Not now.
Okay.
Yeah, okay. Thanks again for your attention. Apologies again for the mishap with the projection. I hope it was interesting anyway, and I'll be around for more questions if you like. Thank you very much.